Good morning friends. Today we will discuss linear regression machine learning algorithm. Linear regression is a supervised machine learning algorithm mainly used to predict continuous numerical values. Algorithm tries to find a line that can represent all data points available in the training dataset. Mathematically, line is represented by y is equal to w0 plus w1x, where w0 is the y-intercept, which is also called bias. w1 is the slope of line, means rate of change of y with respect to x, which is also called weights. Algorithm tries to optimize values of w0 and w1 in iterative way so that overall error in prediction is minimum. Mathematically, we express this by defining cost function, which is calculated by finding difference between actual value and the value represented or predicted using the line. Then squaring this value so that negative difference and positive difference both become same, and then taking average over all such values for each data points. The algorithm we have discussed so far is an example of simple linear where data points are represented by one line only. Here only one input variable x is considered, therefore equation is y is equal to w0 plus w1x. But this may contain two input variables and then data points cannot be represented by a line, rather it will be a plane in two dimensions. In this case, equation becomes y is equal to w0 plus w1x1 plus w2x2. In the same way, it may contain n number of input variables, which is difficult to understand via graphical method, but it is mathematical equation will become y is equal to w0 plus w1x1 plus w2x2 plus w3x3 plus and up to wn xn. What we understood so far is that linear regression tries to find a suitable line for which cost function is minimum in iterative way. But iterations are not totally trial and error basis, rather we have some technique to optimize this to reduce iterations and to optimize overall learning process. One of such optimization technique is called gradient descent. In this method, we modify values of bias, which is w0, and weight, which is w1 at each data points by taking partial derivative of cost function with respect to bias and weight respectively. Once learning part is over and optimized values of bias and weights are determined, next step is to evaluate the model. We use test datasets for evaluation process and try to find how well our model is performing. We mainly calculate three numbers to express accuracy of this model. First is mean squared error, which is also called MSE. This is same as what we have done while calculating cost function, with only difference this time we are doing on test datasets. As per formula, we find average of squared values, therefore it becomes less intuitive to correlate with errors at data point level. However, this method works good for comparison between two models. In order to make this value more intuitive, we take square root of this so that average error becomes more intuitive to know error at data point level. This value is called root mean squared error or RMSE. Third one is R squared. This value is calculated by taking variance into account so that output of value becomes more like a ratio whose value ranges between 0 to 1. Higher value means better accuracy. 1 means best result and 0 means worst. These values are less intuitive but hold great importance as far as statistics are concerned. This completes the linear regression algorithm. Thanks for watching my channel Discovery with Data Science. Goodbye.